Welcome to this third and final video for the lecture notebook for the fifth module on web scraping and I/O. We will finish this notebook discussing some reading and writing of data to files. There are several tools available for reading and writing data to files, including, but not limited to, these popular options. Some basic I/O in Python, which we will explore, Pickle, pandas I/O options, and also scipy I/O options, in particular the SaveMat and LoadMat options. We show some typical use cases for a few of these with some code comments below. Now, you should experiment and really think here. You should make your own activities. In fact, you need to make at least one of your own activities that you also solve in this part of the notebook. You should really think about, as you're learning this, what would you have somebody do to demonstrate their knowledge of this material? Write a reasonable activity for that you would expect to give to a classmate, and then show your solution to it. Make sure to demarcate your activity with cyan borders, as I do often, so that I do all the time, so that I can easily locate and grade your activity. You might just label it my activity, and if you have multiple ones, say my activity 1, my activity 2, and so on. I will only grade one of them, though. You need to have at least one. An implicit, suggested, recommended activity, whatever you want to call it, is for you to also expand and add onto the comments you see below in the code or in markdown cells. Read through the documentation and try out different options that you also comment on in code or markdown cells, and perhaps even create some markdown cells that try to explain the pros and cons of the various methods, scenarios where you may prefer one to another, or anything else you think is useful to comment on. After all, you should make sure these notebooks are something that are useful for you later on in your studies and in your life when you're working through material like this perhaps in the future. This is really about you. Maybe you already have experience working with various file formats containing data. Maybe you do not. Either way, think about the file types you may need, will encounter, or have encountered. This may require you to ask some professors, students, professionals you know, family, and friends, so that you can get a good feel for what you may work on someday. Or try searching online for what file types people typically deal with in practice, or in areas that you're interested in pursuing careers in. You may use some of I have a typo there, so I'll fix that. I'll fix it later. You can use some of the documentation things discussed and linked to in this notebook as a starting point for your searches. Okay. So let's start with the basics. Now notice I normally don't have this tab open, this main Jupyter tab where we launch the notebooks, but I'm going to leave it open here so that you can see these files being created as we work through them. So we will show the basic way of opening, writing. This is the basic I/O in Python. So we're going to show how to open, write, and read a file's contents, assuming the file contains the basic data type of strings. So there's this link here that provides some more details than what we have in this notebook, but you should look at that and maybe add that useful content you see there into this notebook. We will quickly see, though, that there are some annoying limitations to the basic I/O. So look at this built-in function. This does not require any import call. This is just something available in Python. We can open a data file called Broncos_players, and we can use this W to say we want to write into this file. So recall in the part A of this lecture notebook, we created data frames that were scraped from the Broncos official website about their roster. Suppose we want to start writing information into this data frame. So we open this and we say F open. So this creates the file. So I'm using F for file here, is this open file. So now later on you see I do f.write to write information into the file. But let's look at this. And I wanted to point out, if this file already existed, which it does not, you don't see it here, this would delete any file or any data that may exist in that file if that file was already previously created. So you need to be careful. So watch what happens when I run this. Notice this appeared seemingly out of nowhere, Broncos players. And if I open it, notice it is empty. There's no information in there. Okay, so we don't see any player in there, so we can try, if you don't see that data, try refreshing. But this should show up kind of immediately as it did for me. So now we can write strings to this, but not other variable types. even if those variable types are objects that contain strings. So this will produce an error, right? So we're going to try to write the player data, or excuse me, the player. Now look at this. You're saying, well, what are you talking about? You're trying to write an argument. Needs to be a string, not a series. Remember, this is a series data type within the pandas data frame. That is this data frame variable, the data frame for Broncos. So even though that's just a series that contains strings, it won't work. So what I need to do, if I want to create a file that, let's say, stores all the names and colleges of players on individual lines, then I need to do something like this. I need to loop and then I'm going to zip together the two series of the players and the colleges. And then I'm going to take their name, that's from under the player label, and the college, under the college label. I will create a variable string where I have the name, and then I add the name from this data I'm looping through, and then the college, and then the college variable that I'm looping through. And then notice I have a new line command here. And then I write that variable string into this file. So let's run that. Now, let's open this file again. Nothing's there. I thought we just ran this data right here. So like, what's going on? Well, we haven't closed this file yet. So it should appear empty. That's fine. If you want to see if things were written correctly, what we do is we run this code cell. So now this closes. This prevents more data from being written to this file by accident. So you should always close your file object when you're done with it. So now that I've closed it, I can check if the file is closed. So that was close with parentheses. That's a function command. That's a method attached to the file object that when I run it, it closes it. So now if I do f.closed, which checks the attribute, is it closed or open? This is true. So now when I open this, all the data is there. Because I'm done editing it now. Now it displays it for me. It's there present for me to look at. And I see it has that structure of those variable strings like we have, that we wrote to it. Okay. So now, what if I try to read in the data from that file, F? Well, this will produce an error because this was a closed file, so you can't read it now. So you need to open the file in read mode. That's what that R is. So now when I do that and I try to read it, I have a comment here, yuck. Look at that. That looks insane. So now what happens if you try to read it again? Now it's an empty string. So what's going on? When you read from a file, it is keeping track of where it stopped reading, like an internal bookmarking of the data. And if you look for where the bookmark position is, in this case, it's saying 3,277. That's at the end of the file in this case, based on the number of string, the length of the string that it did. So it just read in line by line all this information, and then it was at the end, and there's nothing left, so it's an empty string that it's read in because it's at the end of the file. And if I wanted to change the bookmark object, I can use f.seek and say offset and whence, where offset is how far from a reference point defined by the whence you want to set this position. So a whence value of 0 sets the reference point at the beginning of the file, 1 uses the current file position, and 2 uses the end of the file as the reference point. Whence can be omitted because it has a default value of 0. So then the offset, if I do this offsets from 0, 0, and this will then reset the bookmarking from 3,277 to 0 in terms of where it's trying to read in the data. And now if I want to actually read in the data in a nice way, I should use read lines. So instead of read, which will read in everything, just all as one big string variable, that's all it's done here. This will read in line by line. So it's going to look for these end of line characters. So let's look. Now you see this list and it has this new, all of these things in this new line here. And now I can close this again and then make the remark that this data looks incomplete. Oh yeah, we should have included the player positions in it as well. This would be a nice data file. It has the player names, their colleges, and what position they play. How can we add the player position data to the end of each line? Well, this is where we get to some of the annoyances. This is from a Stack Overflow blurb. This is, unfortunately, there is no way to insert into the middle of a file without rewriting it. As previous posters to Stack Overflow have indicated, you can append to a file or overwrite part of it using seek, but if you want to add stuff at the beginning or the middle, you'll have to rewrite all of it. This is an operating system thing, not a Python thing. It is the same in all languages. So the problem with open is that you can open a file in write mode, which will wipe the data clean in the file to be rewritten. So if you were, for instance, to go back and run this, here we go, open in write mode. If I run this again, look what happens. All the data's gone. It just overwrites it. So I'll just kind of, oops, here we go. Just run through everything here to get to where I want it to be. All right, oops, I went a little too far. You can open it in read mode, which will allow you to view but not edit the comments. And you can do a read-write mode, which allows you to read contents as you write, but you can only overwrite existing data and not insert it in place. Or you can append data at the end of the file. There are no good options with just open that exist for editing lines of data in place that do not simply overwrite the existing data. There are some workarounds, and I provide a link so you could try to search for some options, but we're not going to dwell on this further. We will simply leave this as a suggested activity for seeing if you want to explore how to insert the position data for each player in this data file. But before we move on to the use of pandas IO options, which will be the next focus in this notebook, I do suggest you read a bit more about saving data types more complicated than strings and potentially with more complex structures using JSON and Pickle. But that's not the in the scope of what we're going to study in this course or in this notebook. But if you're really interested and you have some extra time, I highly encourage you to start reading into it. So as far as pandas IO goes, there are a few key points that I have here. If data is already in a pandas data frame object, then that object has several attributes to write the data into files with various formats, including comma separated values, CSV files, and Microsoft Excel formats. Data can be read into data indirectly to a data frame object using various methods available within pandas as well. If working with data in a panel format makes the most sense to you, then the pandas options are probably the best and easiest for you to use. So from that data frame of the Broncos, I should close that file. I was done with that file. So let me F-close. Here we go. There we go. Close that data file there. So now imagine I want to write Broncos roster data to a CSV file and to an Excel file, and notice I need to use either XLS or XLSX when I'm writing to Excel to specify the type of data file. So if I write that there, then you'll see these two data files show up. And I think this is the one here. This says all that information. This is in a comma separated file. Notice how each data in each column is separated by a comma. This is a comma separated data file. And notice there's that missing data from this one that was this person's age wasn't known for some reason. So there's just two commas back to back. So a CSV file, a comma separated file, is all in text format. So we can read it in as a file with open. But why would we do this? Well, let's look at read lines. So we can see all the data here. It's not looking that great. We can open it in and we can close it. Let's not do that anymore. That's just a big list of data and it's not nice. If you wanted to read it in as a pandas data object, you want to use read underscore CSV, just like we had read underscore HTML. That's up within pandas. It's a method within pandas. And then I'm just giving it the data file name that's over here. So now when I look at it, look what happened. It is having this is listing the data and it has this unnamed column with 0 data. What went on here? Can you try to explain what happened? Well, if you look, the labels for the row number were added as an unnamed column, right? There's no name up here. This first column has the labeling. There's no name for it, so that's why it read it in as unnamed. And this, like when I wrote to the CSV file here, and as we see it here as well, it wrote the labeling of the rows into that data file. So you might say, well, geez, maybe I don't want to do that. That's something for you to figure out. You can also read in the Excel data and also this as well. And again, you have this kind of looks like the original data frame and you have these same issues here. So you could look at, maybe are there ways to write in the data that avoids having these labels, this unnamed label data, the row numbers attached to it, because if you read it back in, you would just have those rows to begin with. And if you're reading this data into an Excel spreadsheet, you wouldn't want this either, because it would just be labeled on the Excel spreadsheet. So that would probably be a very good activity for you to make. How to deal with this data and read and write it where you avoid putting in the row numbers associated with it. That would be a good activity for you to create and then provide the solution to. And then provide links of how to do that. So then finally, there's some scipy IO formats that are here. So in a data frame, there is an entry for each row and column. I mean, data may be missing as we've seen, but this is just like an entry of none in a sense. So there's always something, even if it is a type of null data. In computational science, we often generate lots of different types of data in the form of arrays that can have different formats and data types and different shapes and sizes. We also often generate lots of metadata describing details of how the problem was solved. Taken all together, this means a data frame is not necessarily suitable to describe all the data we generate for a typical problem solved in computational science. So while data frames are often nice in data science centered fields of study, if you're doing more computational science or applied mathematics or computational physics or engineering, you might find that data frames are not appropriate for you. And in that case, when you're reading and writing data, you're probably going to want to use the IO provided within scipy, because that's the scientific Python library. And there you can write data files in a .mat format. I'm not going to belabor this point. It involves creating dictionaries. I have everything here for you to read. It's rather short, but I just described how to read and write data in a .mat format, and it also allows you to read and write it into, if you were using, let's say, MATLAB. So that's something for you to work through here on your own. I don't really want to go over it in the purpose of keeping this short, but it is useful to know about. If you're doing more computational science applications and you're trying to save your data, you're probably going to want to use the IO in scipy, because that's the scientific Python library, and it's going to be more appropriate for those data formats than a pandas data frame. So that's just for your general knowledge, and I provide some kind of silly, nonsensical examples here for that. And then finally, there's the summary. And again, please write your summary points and complete sentences that are well aligned with your code examples. So that's it. Thank you for listening, and I will start making a video for the assignment.